One of the triangle similarity theorems states that if you have two sets of congruent or equal angles, then you have enough information to prove the triangle is similar by angle-angle similarity. Now, looking at the two triangles I have here, at first glance you might think that we don't have enough information to prove them similar, because though I see one pair of congruent angles, both of the 100-degree angles, I have two angles that are different, 45 and 35 degrees respectively. Now, one thing we can always use to our advantage is the triangle angle sum theorem, which states that every single triangle has three angles that add up to 180 degrees. So if I do 180 minus 145, I get 35 degrees. On the next triangle, if I do 180 minus 100 plus 35, I would get 45 degrees. So it turns out we do have enough information. Now I can set up a flow chart to prove these similar. It's angle-angle similarity, so I only need two bubbles. And I personally like to put an A up above just to remind myself of what I'm putting in there. Now I need to state the corresponding angles that are equal. So I can say the measure of angle Q is equal to the measure of angle T, because both of those have a measure of 100 degrees. Alternatively, you could say angle Q is congruent to angle T. Now the other angle that I'm going to use, I get to choose. I could use both 45-degree angles or both 35-degree angles. I'm going to choose to use the 35-degree angles. So I will say the measure of angle R is equal to the measure of angle U. And again, I could say that angle R is congruent to angle U. It's kind of a personal preference. Now, because it's angle-angle, I now have enough information to say that my two triangles are similar. So I'm going to start with my triangle on the left. I'm going to do triangle PQR is similar to triangle STU, being careful to go in that corresponding order. So in the first triangle, I went from the 45-degree angle to the 100-degree angle to the 35. So I will do the same thing on the second one, which again gets me STU.